Okay, Leonardo, so the summary, it will be like this. Given the function theta equal f of xy, that is a surface, to find the normal, the tangent plane to the surface, we need to find the normal to the surface at the point of consideration. How we will do? We construct the new function f of x, y, and z. How? It will be the level surface. It will be f of xy minus z. Now we know that gradients are normal to level surface. What is the normal, what is the gradient of this function? The gradient of this function is f of x, is the coefficient that to construct the plane will be f of x, x minus x0, fy, y minus y0, fz, theta minus s0. Who is the derivative of f in respect to the x? Will be f of x, little f of x, is because x is only here, it's not here. They are independent variables. Who is the derivative of capital F of respect to the y? Is f of y. Who is the derivative of capital F respect to z? Is minus 1, minus 1. So the linear approximation will say, if you play with this equation, will say that if you put theta minus theta 0 in this side of the equation, zeta minus zeta 0 will be f of x by x minus x0 plus f of y multiplied by y minus x0. So if you are walking in the plane, this is the linear approximation. Compare this with the differential of c. Is the same thing. So this is what you have to know. The key idea is the gradient is normal to the level surface. The level surface are constructed like this. For example, given your function f of x comma y equal 5 minus x squared plus y squared. The level surface f equals 0 is constructed like this. F of x comma y comma c is the function f of xy minus z, meaning is 5 minus x squared plus y squared minus z. And because 5 minus x squared plus y squared is z, this is the level surface f equals 0. If I have the function f of x, y, z equal 5 minus x squared plus y squared minus z. If I have, minus z. If I have this function and I want the level surface equal 1, this refers to the function theta equal 5 minus 1 is 4. I put the theta at this side. Theta equal 4 minus x squared plus y squared. So what happened? The first level surface was this one. This one was the level surface where f equals 0 and is the function theta equal 5 minus x squared minus y squared. Now, the level surface f equal 1 is this function. And who is the function? Is the function theta equal 4 minus x squared minus y squared is this function. So this is f equal 1. So the gradient is going in the direction where f increase. So the gradient in this case, wow, is going inside, is going in this direction. So I made a mistake on the next video that indeed I did it before this one. Okay, well, I hope you catch all the ideas. I hope. Good luck. Anything, let me know. Hi, Leonardo. Well, we are going to discuss tangent planes to surface. The first idea of the tangent planes is like this. You remember, for example, that if you have a function, let's say y equal e to the x, e to the x. So the function e to the x does like this. X equals 0 is 1, and it grow up. Imagine you want to approximate the function by a tangent line. What you will do? Suppose that I want to approximate the function on the point x equals 0. On the point x equals 0, the function does like this, but I may approximate the function by the tangent line. So this is the tangent line. And the tangent line is the function y of x equal y0 plus m by x minus x0. So the tangent functions to the function e to the x at center at x equals 0 is y of x equal y of 0, 1. Y of 0 is 1 here, plus m is the derivative, the slope, is the derivative of the function evaluated at x equals 0. And the derivative of the function at x equals 0 is e to the x, evaluated at x equals 0, so it's 1. So it will be the linear approximation to this function. It will be 1 by x minus 0. If I want to find the linear approximation of e to the x at x equal 2, I will do the same. The linear approximation will be this line. It will look very near x equal 2. It will look very near to the function. And the linear approximation at x equal 2 will be y of x equal y of 0 e to the 2. Sorry, e to the 2 plus the slope is the derivative of the function evaluated at x equal 2. Oh, the derivative of the function is e to the x. At x equal 2 is e to the 2. E to the 2 multiplied by x minus 2. And this equation is this line, this rectilinear line. Okay, what I mean is that you can always approximate next to the point a function by its tangent line. Now we don't have a function. On this course we have a surface, and we need to approximate the surface by a tangent plane. So the whole thing here, the whole is giving the surface, let's say the surface that you have chosen, the surface, giving this surface how to find the tangent plane to the surface. The tangent plane touch the surface in one point. So imagine that this is the point, and I need to find, I don't know if I will do a good, the plane that touch the surface in one point. And I want to find the equation of a plane. And this is what we are going to discuss. The equation of a plane that touch one point of the surface. So given the function f of xy, given f of xy equal, I think you wrote 5 minus x squared plus y squared. Or, or maybe you wrote like this, 5 minus x squared minus y squared. That is the same. sorry. Well, given this function f of xy, that is an inverted paraboloid like this one, what is the vector that is perpendicular to the surface? What is the plane that touch one point of the surface? And the second question is, what is this vector? The vector that is perpendicular to the surface. So let's go to find the equation of the plane for this case. The first things that we have to do is, let's go to do something first. Let's go to talk about level curves and level surface. Let's go to right. Level curves and level surface. There are two different things. So what surface? What we are going to do is that the gradient, that is a vector, the gradient is perpendicular the gradient to the level curve. Let's go to write it correctly. The gradient to the level curve is perpendicular to the level curve. And what we will see is that the gradient to the level surface is perpendicular to the level surface. What will mean this? Okay. Well, what I should have said is the gradient is a vector that is perpendicular to the level curve. And the second thing that we will see is the gradient in space in 3 dimensions, x, y, and z. The gradient is a vector that is perpendicular to the level surface. Sorry that I wrote it differently. What will be this? We have this, let's say this function, the function y equal 5 minus x squared minus y squared. So is this function, Okay, it's an inverted paraboloid. So, sorry, it's not y, it's theta equal 5 minus x. Yeah, I wrote it here, yeah, f of xy with this theta. Theta equal 5 minus x squared minus y squared. What happens if I intersect this function with the plane theta equal 5? Do you see the plane theta equal 5 is the plane who is parallel to the plane xy? Theta equal 5 is the plane that is parallel to the theta to the plane xy with height 5. Now, what will be the intersection with the plane theta equal xy of the of the function 5 minus x squared minus y squared? So it will be, if theta is 5, the equation that I will write, it will be 5 equal 5 minus x squared minus y squared, then x squared plus y squared will be 0. So it means that this point is the point that exists at theta equal 5. At theta equal 5 exists only one point. At theta equal 4, what exists. At theta equal 4, I will write 4 here. 5 minus x squared minus y squared. It means that x squared plus y squared equal 5 minus 4. 5 minus 4 is 1, you see, because it's the minus sign here. So at theta equal 4, what exists here is a circle. At theta equal 4 exists a circle of radius 1. At theta equal 2, what exists is a circle of radius square root of 3. So, um, so what is the level curve? This is the trace. What I'm talking is about the trace. But what is the level curve? The level curve exists, the trace exists at theta equal 5, or is a point. At theta equal 4 is a circle. At theta equal 3 is another circle. So you can help yourself to draw the function by knowing the trace. So you can make the trace, for example, parallel to the plane xz. So, for example, y equal 1. If you choose y equal 1 here, y equal 1, and you make the intersection will be a parabola inverted also. You can do it. Okay. So, I'm going to talk about the level curve. So, at theta equal 4, what is the level curve? The level curve means in the plane xy, so this is the x and this is the y, what are the set of points that exist in the plane xy whose height is 4? So I will do something similar, and I will place theta equal 4, and I will have the equation of a circle of radius 1. It means that if I put a radius 1 here, the set of points that have height 1 is on this plane xy, and this is the level curve. So this is theta equal 4. Theta equal 4, the level curve for theta equal 4, for all the points that have the height 4, is a circle of radius 1. And this circle is on the plane x comma y, and the gradient of f, the gradient of the function f comma y, the gradient of f comma y, let's go to find the f of xy is 5 minus x squared minus y squared. The gradient is minus 2x minus 2y. And the gradient is a vector ij, is a vector that is pointing in the direction where the function increase at maximum. So if you see the picture, you see that this vector minus 2x minus 2y, let's go to write it in the plane xy, this is the circle where theta equal 1, and the gradient is pointing, wherever you place, is pointing in this direction. If you choose the point, let's say, x equal square root of 2 and y equal square root of 2, is a point whose x squared is 2, y squared is 2, x squared plus y squared is 4. So x squared. Okay, so if you choose the point 1 divided by square root of 2 and y equal 1 divided by square root of 2, now this is a point that is on the circle, on the level curve. So if you choose this point, the gradient is pointing in the direction 2x2 divided by square root of 2 I minus 2 multiplied by 1 divided by square root of 2j. So the gradients at the point 1 divided by square root of 2 comma 1 divided by square root of 2 is a vector that is pointing in the direction where the function increase at maximum. In this direction, this is the direction that the function will increase at a maximum, means with the distance smaller. What will be this level curve? This level curve will be when theta is more than 1 or less than 1. When theta is more than 1, theta equal 2. See the picture here. As you move, let's say that I'm here in this circle, as you move, the radius will decrease. So, and the height will increase. So theta equal 2 is the smallest circle. So what will be the gradient here at this point? The gradient will be minus 2 times divided by square root of 2i minus 2 times divided by square root of 2j. So the gradient will be minus square root of 2i, because 2 is square root of 2 by square root of 2, minus square root of 2j. So this is the gradient, and the gradient of the function f point in the direction perpendicular to the level curve. And this is not the vector that we need to use to find the plane, the tangent plane. Okay, what is the vector that we need to use? We construct the function f, capital F. In your video, the capital F that you write it looks very similar of F. So I would say write a good capital F. So how we will do how we will find the tangent plane to the surface? Let's go to write it. To find the tangent plane to the surface, we need the normal vector to the surface. Oh, and how we will find the normal vector to the surface? We construct the level surface. We construct the level surface. What is the surface that we'll construct? The level surface, capital F, of x, y, z equal f of xy minus z. So what is f of xy? Is 5 minus x squared minus y squared minus z. So this is a new function that we construct, and what we say is the vector. So this function is 0. So this is the level surface, the surface f equals 0 for the function 5 minus x squared minus y squared. So imagine that you have the function capital F is the temperature. So you have a function whose temperature is 0 in all these points on this surface. On all this surface, the function is 0. When you move to this is T, temperature. So when you move from point to point, the temperature is 0. So if the temperature is 0, this is the level surface, the surface where the temperature is 0 for the function 5 minus x squared minus y squared minus z. Should be 0 because theta is 5 minus x squared minus y squared. So this minus theta should be 0. Okay, so this is the level surface. And how we will find the normal vector? The normal vector is perpendicular to the level surface. So I have the level surface. The level surface f equals 0 is 5 minus x squared minus y squared minus z. And the gradient of f, this is f of x comma y comma z. And is the level surface when f. What is the gradient of f? The gradient of capital F is the derivative of f respect to x. So let me think something. The normal vector go outside, so I need to construct the function, not this function f of x, y. Let's go to construct this function. Let me erase here and put it in opposite. The function zeta minus x squared minus y squared plus 5 plus 5 or zeta minus x squared plus y squared. Let me see the function here. It was 5 minus x squared minus y squared. So I'm going to construct the function 5 minus zeta minus 5 times minus x squared minus y squared. And now I'm going to find the gradients. I want the gradient to go in the opposite direction. That's why I changed what I said. So now the gradient of f is the derivative of f respect to the x, to xi. The derivative of f respect to the y, to yj. The derivative of f respect to the z, 1k. Now this is the gradient. This is a vector. And the vector points in the direction perpendicular to the level surface. Perfect. And now what is the gradient at the point, let's say 1, 1, 1? The gradient of f is 2i plus 2j plus 2k. And what is the normal vector at the point x0, y0, zeta 0? Is the normal plane is the coefficient are ABC 2, 2, 2. So to construct the tangent plane, we'll do like this: 2x minus 1 plus 2y minus 1 plus 2c minus 1. Well, I have chosen at the point 1, 1, 1, so this is x0, y0, zeta 0, and this should be equal 0, so this is the equation of the plane, and I can play 2x plus 2y plus 2z minus 2 minus 2 minus 2 is minus 6, minus 6, or the plane is x plus y plus c minus 3. So d equals 0. So this is the tangent plane to the surface. So why is interesting to find the tangent plane? Because the tangent plane touch one point of the surface, and you can approximate next to the point the surface, the level surface can be approximated by the tangent plane if you don't go very far from the point x0, y0, zeta 0. So it's the same idea of the linear approximation in single variables. Well, I think that I have said most of the things that I have to say. Maybe I have to say something else about differential of f. When you make a small change in z, so you move the point x0, y0, you move it in some direction. So you move to the point maybe 1.1 and 0.9. The z, you don't move it. You want to see what is the change in the function. So, sorry, but I made a big mistake because the point 111 is not on the surface. 111 is not on the on the on the on the level surface, because the function is theta equal 1, 5 minus 1 minus 1 is 5 minus 2, 5 minus 2 is 3, yes, 1, 1, 5 minus, so it's the point 3, here is 3. So now have sense. So the gradient of f here is a 1. I don't know why I put a 2. Yes, I know what it is. So let's go to do it again. So let me erase. So the point is the point 113 because it's the point that belongs to the surface. At the gradient at this point, is the gradient, the vector at this point is 2x, 2i, plus 2y, 2j, plus 1k. 1k, oh, because they have no z. Okay, so this is the gradient. And the plane is 2, 2, 1, x minus 1, y minus 1, z minus 3 equals 0. Perfect. And now see what happened. 2x minus 2 plus 2y minus 2 plus z minus 3 minus 4 minus 3 is minus 7 equals 0. See what happens. Theta equal minus 2x minus 2y plus 7. What it means? That the function theta equal f of xy equal 5 minus x squared minus y squared can be approximated by this function on the near the point 1, 1, 3. So now you can use this equation to find what will be to x to y plus c. What will be the change in c if you move the point x and y? For example, you are at the point 1, 1, 3, and now you move to the point, to the next point, but through the plane. You are walking through the plane. Now you are not walking any longer to the surface. You are walking to the tangent plane. Now imagine that you move to the point 0.9, 1.1, 3. comma 3, no, comma, C. Oh, and you want to know who is C? Who is the new height at this point? So the zeta at this point will be minus 2 times 0.9 minus 2 times 1.1 plus 7. So 2 times 0.9 is 1.8. 1.8 minus 2 times 1 is 2.2 plus 7. So the new C at the point 0.9111, it will be what I say to 2 multiplied by 0.9 is 1.8, no? 1.8 I said. 0.9 by 2 is 1.8. Minus 1.8 minus 1.2, this is minus 4 plus 7. Minus 4 plus 7 is 3. So if you move through the plane, you don't check the C. Wow! In this, how is possible the plane have a direction, have a slope? This is not possible because, yes, it's possible. Is possible. So you don't change the C in this case. C equals 3. You see C equals 3 for the point 1,1. Now for the point 0.111, the C is always 3. Let's go to do it with this equation. C equals 5 minus x squared plus y squared. So C equals 5 minus 0.9 squared x squared plus 1.1 squared. Using the calculator would be 5 minus, using the calculator will be 0.9 is 0.81, 1.1 squared is 1.21, doing the subtraction is 2. So the point is 2.98. The point on the surface of the function, when you change from this point 113, the new C is 2.98. When you move from 113 to 0.911, 1.1, the C approximation, when you move to the point 0.98, 1.1, the new C approximation walking through the tangent line is 3. The correct and exact Z when you move from the point, when you move from the points, when you move when you are at the point 0.9, 1.1, the exact C is also 3, almost 3.